What's going on YouTube? Tom here, and in today's video I'm going to be teaching you how to create your first video game in the Godot engine. So let's get started. Okay guys, the first thing we're going to want to do is download the Godot engine. To do that, open up your web browser and head on over to godotengine.org. Once we get there, you'll see this splash screen here telling you all about the Godot engine. We've got various things here such as the Learn tab, which is really useful for going through all of the documentation for Godot. But for now, we're just going to click on the download link. Once we get there, you'll see that there's a few different options that you've got for downloading Godot. I would suggest that you go with the standard version for now, either 32-bit or 64-bit, depending on what your operating system supports. I'm going to click on the 64-bit, and it's a really small download. It's 22.5 megabytes. Once you've got the zip file, open it up, and you can literally just drag the Godot executable file anywhere onto your machine. Godot's a portable engine, so you don't have to install it, you don't have to do anything like that. You can literally open the zip file, extract it somewhere, and run it from wherever you choose. So I'm going to drop it onto my desktop, and then you want to launch the Godot engine. The first thing you're going to see when you launch the Godot engine is the project manager screen. Now it's going to ask you, do you want to explore the official examples? Do you want to go to the asset library and download some tutorials? We're not going to do that right now, but just to be aware that there are tutorials out there. There are templates available for 2D games and 3D games alike in the asset library for Godot. So I would highly advise you check those out once you get some time. But for now, we're just going to click cancel and we're going to create a new project. So for this project here, we're going to basically be recreating the essence of Space Invaders. We're not going to do the whole thing, but we're just going to get to grips with Godot as an engine. We're going to get to grips with the user interface, and we're going to start doing a few little bits of scripting just to make sure that we can understand how this works. And we'll get to the point where we can create a Space Invaders game with a player, bullets, and ships, and you can kill the enemies. And that's all we're going to get to today. And hopefully that should give you enough to go on to create other projects in the future. So to give this a project name, we're just going to call it Space Invaders. We're going to choose a path. I'm just going to create a new folder here. I'm going to call it Space Invaders. Select the current folder. And now you've got two options. You can either choose OpenGL 3.0 or OpenGL 2.0 for your renderer. Now, OpenGL 3.0 is the most up-to-date one that Godot supports. It's for high-fidelity games. Good graphics, 3D games, 2D games, they're all supported, but it's incompatible with some older hardware. Now, it's probably the most used option in Godot right now, I would have imagined. 2.0 is useful for if you're trying to support older mobile devices or potentially just older hardware in general. But for now, OpenGL 3.0 is fine, so we're going to choose that and we're going to press Create and Edit. Okay, so this is the Godot engine. If you've used Unity before, then you'll probably feel very familiar with this. On the left-hand side, we have our scene hierarchy. So this is where all of the nodes within our scene will live. If you're completely new to this and you haven't looked at Unity before, don't worry, I'm going to explain what everything does, and then we can go on from there. So on the left-hand side, like I say, this is the scene view. Every single thing in your game's scene will live within this view, and it will be in a tree hierarchy view. So for example, if you had a player and he had a weapon and maybe he had some other things underneath him, they will be structured out in such a way that the player will be the top level element and then all of the things such as his weapons will be nested inside of him. So we've got the scene view on the left hand side. Then we have our file browser on the left bottom. This is everything within our project folder. So we can have sprites, artwork, textures, materials, scenes. Basically, everything that makes up your game will live inside this folder here. In the middle, we have our scene view. So this is our actual 3D or 2D representation of our actual game and the scene that we're working on. On the right-hand side, we have something called the inspector. Now, the inspector displays properties and allows you to modify those properties of the game object that you currently have selected, and we'll see that in use later on. Up at the top here, we have different tabs. Now we can switch between 2D view, 3D view, our scripting text editor, and the asset library itself. So because we're making a 2D game, we're making Space Invaders, we're going to switch to the 2D view. And on the left-hand side, it's asking us to create a root node. So again, because we're making a 2D game, we're going to click on 2D scene. Now what you'll notice is on the left hand side here now, that has changed to node 2D. So this is our root node. in our scene. Again, like I say, everything is in a hierarchical format. So everything has a root, and for a 2D game, we have this 2D node, which everything underneath that will be part of our scene view. On the right hand side, you'll also notice that the inspector window has changed. We've now got node 2D listed here, and we can see all of its properties such as its position, its rotation, and its scale. What I like to do is I like to right click on this node up here, and I just like to, it's personal opinion, you don't have to do this, but I like to rename it. I like to rename it to world, just so that it's clear that this is the root node for our entire world. Okay, so now that we're set up with Godot, we've got our engine open, we're ready to work in a 2D way, we're going to start importing some resources. Now, I've created a few little pixel art sprites for this game. I'll list the download link in the description below so you can go and pick those up as well, but feel free to use your own if you've got some. What I'm going to do is I'm going to open up my file browser. I'm going to head on over to my pictures folder, which is where I've stored them, and you'll see here I've got bullet, enemy, and player. I'm going to drag and highlight those, drop them into my res folder, and now you can see that they're listed here. We've got bullet PNG, enemy, and player PNG. The first thing I'm going to do is I'm going to right click on my world node, and what we're going to do is we're going to create the player. So we're going to add a child node to this world. Now we have lots of options here in this create new node screen. Feel free to go around and have a look and see what you've got available. There's absolutely tons of stuff in here. We won't be using most of this stuff in today's tutorial, but we might touch on them later on. The first thing we're going to want to create is a kinematic body 2D. Now, a kinematic body 2D is a physics object, and basically a kinematic body is a physics object that you can control via code. It doesn't interact with anything in the scene of its own free will, so it's not a physics object that will react to gravity and bounce into other things just on its own. You would have to program all of that yourself. So kinematic bodies are great because they have collision detection, they can move, and they can have all of the physics interactions that other physics objects have, but you have complete control over them via the code that you write. So we're going to create our player object as a kinematic body 2D. We're just going to rename this by right-clicking and pressing rename. You can also click on the element and press enter, and that will do the same thing. And we're going to call it player. Now you'll notice here on the right-hand side, we've got this little warning triangle, and it says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D. So we're going to do that as well. So we're going to right-click, we're going to add a child, and we're going to add a collision shape 2D. Now, you might be thinking, well, we still don't have the player actual image there. So, yep, you're right, we're going to add another child node, and this time it's a sprite. So with the sprite selected, we're going to come down and find our player PNG. We're going to click and drag that over to the right-hand side in the inspector. And where it says texture empty, we're just going to drop it in there. And you'll see in our scene view that that's reflected, and our player sprite is now visible in the scene. You'll also notice that on the left-hand side, the collision shape 2D also has a warning triangle now. And it says here, if we click on it, a shape must be provided to the collision shape 2D for it to function. So we're going to click on that. And over in the right-hand side in the inspector, where it says shape, and it currently says empty, we're just going to click the drop-down, and we're going to choose new rectangle shape 2D. Now, if you look over in the scene view here, you might have noticed that a tiny little square has appeared where the collision shape 2D is placed. We're going to zoom in. We're going to use our middle mouse button to pan around the scene. And you can see these two little handles here. We've got one for the y-axis and one for the x-axis. What I'm going to do is I'm just going to click and drag until that covers the entire sprite. Now, what you could do if you're wanting to be a bit more precise about your collision box, you could drag this down about halfway. You could stretch it again so that it fits a little bit more snugly around the player element itself. You don't have to do that, of course, it's completely up to you, but that's just to show you that you can do that. And this is basically our player object now. We have our player, which is a root node kinematic body 2D. We have a collision shape 2D to define the bounding rectangle of our player. And we have the sprite, which defines the actual image that the player is going to represent. Okay, so we're going to do the same thing. This time we're going to do it for the enemy and for the bullet. So I'm just going to click on the player node here. I'm going to press W on my controller, or you can click the icon up the top left here for move mode. And we're just going to drag this out of the way for now. Again, we're going to collapse the player, and we're going to right click on the world node, and we're going to add a new child node. And we're going to do exactly the same as we did for the player node. So we're going to add a kinematic body 2D. We're going to rename it by right-clicking and pressing rename, and we're going to call it enemy. We're going to right-click the enemy, add a child node. It's going to be a sprite. Again, right-click the enemy, add a child node, and we're going to add a collision shape 2D. For the sprite, we're going to drag in enemy.png over to the texture in the right-hand side inspector. For the collision shape 2D, over on the right-hand side where it says shape, we're going to choose new rectangle shape 2D. And then we're going to zoom in and we're just going to drag these handles again, the Y handle and the X handle, just to make sure that the collision rectangle is covering the entirety of our sprite. We're going to collapse the enemy and we're going to right-click the world node, add child, and we're going to do the same thing again one last time for the bullet. So we're going to rename this to bullet. We're going to right-click, add a child node, add a sprite, right-click the bullet again, add a child node, add a collision shape 2D. Over in the right-hand side, we're going to choose shape, new rectangle shape, click the sprite, drag the bullet.png over to that. And the collision shape again, we're just going to drag this down a little bit, just so that it covers the actual bullet itself. And there we go, we're going to collapse the bullet. Okay, so we now have a bullet, we have an enemy, and we have a player. Great. So the next thing we're going to want to do is make the player be able to move left and right, depending on if the user is pressing the left or the right key on their keyboard. To do that, we're going to zoom out, and the first thing we're going to want to do is we're going to move the player down to the bottom of the screen. Now the screen's bounds are defined by this rectangle here. So we're going to place the player roughly about here on the screen, which is kind of about the middle bottom. Before we do any of that, there's one thing that I need to mention about Godot and the way it works. If you're familiar with Unity, Unity has a concept of prefabs. Now prefabs are objects that you can create that can be reused in your scenes. So it's really handy if you're creating something that you want to duplicate multiple times throughout your scene, and then if you want to make a change to that object, you don't want to have to go and do it 10, 15, 20 times. You just want to modify one thing, and that change gets replicated across all of the instances. Now Godot has something similar to prefabs, but in Godot everything is known as a scene. So your game world is a scene, your menu might be a scene, your player might be a scene, and everything like that. So everything is a scene within the Godot universe. So to do that, we're going to convert our players and enemies and bullets into a scene. It's quite easy. You right-click on the player and you press Save Branch as Scene. Now, just to keep everything nice and tidy, I'm going to create a folder here and I'm going to call it Player. And I'm going to save this as the player scene, so player.tscn. We're going to save that. You'll notice now in the scene view on the left-hand side, we've got this little movie icon here. Now that represents that this node in the scene hierarchy is a scene itself. We can click on that node and we will then be presented with the actual player scene itself. You'll notice we've got a new tab at the top now and we're just looking at the player scene. So all of the enemies and the bullets have disappeared and now we're just looking at the player scene. We can close this tab and we're back to the main scene. We're going to do the same thing with enemy and bullet. So right click on enemy, save branch as scene. We're going to go up a folder by pressing this little arrow at the top left here. Create a folder, call it enemy, save the enemy scene. Again for the bullet, right click, save as branch, save branch as scene, go up, create a folder, call it bullet, save the bullet scene, and there we go. Each one of our entities now is its own scene. Okay, so we're ready to start scripting our player. To do this, we're going to click into the player scene, we're going to right click the root player node, and we're going to press attach script. You'll get this little window pop up that says attach node script. It'll allow you to choose a language for the script. Now, I'm going to recommend that we stick with GD script here. It's a scripting language specifically made for Godot that is sort of based on Python and has some fantastic little perks that allow you to make games really, really simply in Godot. There are other options, of course. You can program in native script, Visual Script, you can do C#, and there's various other bindings for Godot that you can use. But I would highly recommend that you stick to GD script if you're new. You can see that it inherits from a kinematic body 2D. Now the reason it does that is because the root player node that we created was a kinematic body 2D, and with the script inheriting from that, it means we're going to get access to a whole host of cool functions such as move and collide, move and slide, and various things relating to physics. We're going to come down to the bottom, we can leave the rest of it as default, and we're just going to press create. And now you'll see that the scene view has changed to a scripting environment. What's great about Godot is that you don't need to use any external coding tools like Visual Studio or Visual Studio Code to actually create the game logic within your game. Godot has its own development environment built right into the application. So you never have to leave this. You can write all of your code, test it, debug it. It's got syntax highlighting, code completion, and it has built-in documentation right inside the editor itself, which is fantastic. You'll see here at the top of the script, we're extending kinematic body 2D. Again, like I said before, that just means that we now have access to a bunch of functions that are going to allow us to manipulate this object with physics and a bunch of other things like that. Below the extension, it's telling us that we can declare some member variables here. So we are going to declare one here. We're going to say var speed equals 100. Now I'll show you what this does in a moment, but for now we're just going to move on to the next piece. It says this func_ready is called when the node enters the scene tree for the first time. So when our node gets instantiated, this function is going to get called and we can do some setup work in here. For now, we're not really going to do anything other than the fact that we are going to replace this line here where it says replace with the function body. We're going to replace it with set underscore physics underscore process, and you'll see that we're getting some code completion, so we can press enter to do that straight away. And you see that this takes a boolean. A boolean is a true or false value. Now I will be going into some of programming basics and GD script basics in another video, but for now we're just going to type true. We're going to say that yes, we want to set the physics process to enabled. And underneath that, you've got another function here called func_process. And this says it's called every frame and that delta is the elapsed time since the previous frame. So we get access to this variable here called delta, which tells us how much time has elapsed between the previous frame and the current frame. And that's really useful for being able to make frame rate independent things like movement speed, things that you really don't want to depend on whether or not your game is running at 30 frames a second or 60 frames per second. You want the movement speed to be consistent, and delta comes in handy there. We're actually going to delete this for now, and because we use the physics process, we're going to do something similar, and that we're going to say func space underscore physics process, and again we've got code completion there. We can just press enter, and there we go. So we've got the physics process function here. The next thing we want to do is we want to respond to keyboard input. So if the user presses left or right on their keyboard, we want our player to move left and right in the game. Now to do this, we type if input with a capital I dot is underscore action pressed. We open brackets and we get some code completion here. Now there are some built-in actions in Godot. They all start with UI underscore. Now we can add our own, but for now, UI underscore left and UI underscore right are going to be exactly what we need. They're representing the left and the right arrow on our keyboard. So we're going to choose UI underscore left, close brackets, and all statements like this have to end with a colon, just like the func statement above it. We press enter. And this is where we're going to start using some of the functionality of that kinematic body 2D. Now, I mentioned before that you can get access to the documentation directly within Godot, and I'll just show you how we do that just before we move on to use this function. If we highlight kinematic body 2D here, we can right click on it and press lookup symbol. And this will open up the documentation for this kinematic body 2D directly in the editor. This is fantastic, and you will be using this a lot to go and figure out what properties and methods that you have access to on various objects within Godot. If we come down into the methods section, we can see that there is a method here called move and collide. Move and collide returns a kinematic collision 2D, which we can dive into a little later on. And it accepts a relative vector. So what we want to do, how much we want to move this object by when we call that function. So we're going to go back to the player.gd script here, and we're going to make use of that function. So we're going to say move underscore and collide, and it wants a vector 2 for how much we want to move on the x and y axis. To do that, we simply type vector2 with a capital V, open brackets, and now you can see here the code completion is telling us that we need to pass an X value and a Y value, X being the horizontal plane and Y being the vertical plane. So when we press left on the keyboard, we want our character to go left on the screen. That's negative in the X-axis, so what we're going to do is we're going to say negative speed, which is the variable we created up here to define how fast our player is going to move, multiplied by delta. Now what that's saying is, we want this character, when we press the left key, to move 100 units left per second. So multiplying by delta basically means we want to do this per second. And then for the y-axis, we don't want to do any changes there. If the user's pressing left on the keyboard, we just want it to move on the horizontal axis, not on the vertical. So we can pass a 0 there. Close that, and then close the move and collide function. On the next line, we want to say elif, which is if that wasn't true. So if the input UI left is not being pressed, we can say input.isAction pressed UI underscore right. So if the left key isn't being pressed, is the right key being pressed? Well, if it is, we want to say move and collide. This time we're going to pass a vector2, and we're going to say positive speed, because we want to move right on the x-axis, which is a positive number, multiplied by delta. Again, we don't want to move anywhere on the y-axis, so we're going to say 0, close both of those brackets, and we're done. So if we press save there, what we're going to do now is we're going to come into our main scene by going to the 2D view at the top. And what we're going to do is, you can see it says unsaved here. So we're just going to make sure that we save this scene by going to scene, save scene, and we're going to call it main. Alright, so now we should be able to, you can see on the left hand side we've got the script attached, so we should be able to press the play button at the top right here. It's going to ask us to define a scene to load, which we haven't done yet, so we press select, choose our main scene and press open. Now the game's going to load, and if we press left on our keyboard, the player is going to move left, and if we press right, he's going to move right. Brilliant. Okay, the next thing we're going to do is we're going to make it possible for the player to shoot a bullet whenever we press the spacebar on our keyboard. So there's a few things we have to do here. The first of which is we have to define an action in our input map to map the spacebar to a particular action within the code. To do that, we're going to come up to the project settings up here, project settings. We're going to click on input map. And you'll see here are all the UI underscore actions that we saw in the drop down earlier on. We're going to enter in the text box here. We're going to add a new one. We're just going to say fire. Press the add button and it will get added to the bottom here. Press the plus icon on the right hand side and you can assign a key, a mouse button, a joystick button. We're just going to assign a key. It's going to ask you what key you want to do. You press the space bar and then click OK. And then we can close that. And now we have a new action defined that we can respond to in our input controls called fire. We're going to come back into our player script. And in here, we're going to add a new line into the ready method. And this is going to be set underscore process is true. So if you remember when we first opened this script, there was a commented out piece of code that said the process method runs every single frame. Now we changed that to physics process because ideally you should be interacting with physics. So whenever you're moving and colliding and things like that, you should be interacting with those bits of code in the physics process function. But for things like firing that don't necessarily relate to the physics and moving and collision and things like that, it's quite all right to have that in the standard process function. So we're going to enable the standard process function for this entity. We're going to create it, func underscore process, and you can see that it's code completing for me, which is great. And now what we're going to do is we're going to say if input dot is action just pressed. So did we just press this button? Not is it continuously being pressed like the left and right keys, but did we just press and release this key? And now you can see our new fire action has come up in the drop down list there. We're going to choose that one. So if we have just pressed the fire key, we want to basically spawn bullet. So I'm just going to put a comment in there. Comments are preceded by a hash symbol. We're going to spawn a bullet if we press the fire key. So how do we do this? we're going to save this script and we're going to come back into our main world scene. Now you can see here that we have this bullet. And what we did with the bullet is we saved it to a scene, and you can see as I hover over bullet here, it says instance is called res://bullet/bullet.tscn. Now we can actually delete this bullet from the scene entirely by clicking on it and pressing delete. We can choose OK. We don't need it in our scene because we're going to create instances of this programmatically. So how do we do that? We go back into the player script, and at the very top here, we're going to create a new variable. We're going to call it var bullet equals, and there's a function called preload. What preload does is it allows us to specify a resource path to a scene or to an image or anything else that we have in our file structure. But for this example, we're going to use a scene. So you can see there we've got bullet.tscn. We can hit enter there. And now we have access to that file, to that scene, to that object within our game. What we're going to do to be able to spawn this bullet is we're going to say var bullet instance. So we're going to create a brand new instance of a bullet, and we're going to say that equals bullet.instance. That's going to create a brand new instance of the bullet object for us. Now, we don't want the bullet instance to just appear at the top left of the screen. We want it to appear exactly where our player is. To do that, we're going to say bullet instance dot position equals excuse me. Now we could give it the exact position of our player by just assigning position, but we might get some collisions between the actual player object and our bullet. Now we could avoid that in various different ways, but what I like to do here is assign it a new vector 2. For the x-axis, we want to say our position.x, and for the y-axis, we'd like to say our position.y minus 20. So that's just going to give a little bit of top padding there. So the bullet's going to appear just above where the turret is on our player sprite. The next thing we're going to do is we're going to want to add this to the actual game scene. To do this, we can do something called get_tree. Now what that does is it gets the actual tree structure here within our scene, so it gets the hierarchy. Now that's no good on its own. What we need to do then is get the root node, which is this world node. To do that, we can say .get_root, which is going to get us this world node. And then we want to add our new bullet instance to that root node. We want to place it in the scene. To do that, we say .add_child, open brackets, and pass in the bullet instance. Okay, we're going to save that. And now what we're going to do is we're going to come to just one thing to note there, actually. That line is highlighted. It's saying there's an error. We forgot our semicolon at the end of the if statement. We're going to save that. Everything looks fine there. We're going to come back to the 2D scene view. We're going to press the play button. And now we should be able to move our player character left and right. And if we press the space button, you'll see that we get a new bullet appear just above where the turret is. We can move him across, press the space button again, and we're going to keep getting bullets appear every time we press space. That's great, but the bullets aren't moving. So the next thing we need to do is write a script for the bullets to make them move. We're going to close this. Okay, so what we want to do is we want to come down into our bullet folder in the file system here. We're going to double click on our bullet scene. This is going to open it up in a new tab, and you can see here that we have our bullet sitting in the structure there. We're going to right click on it. We're going to attach a script just like we did for the player. We're going to leave everything as default. We want it to inherit from Kinematic Body 2D, and we want to use GD script. We're going to press create. And here we're going to choose a speed for the bullet itself. So var speed equals, and we're going to want this to move a bit faster than the player. So let's say 500. Again, we're going to want to make use of the physics process. So we're going to say set_physics process to true. And we're going to create the physics process function _physics process. And here what we want to do is we basically want to make the bullet move upwards all the time at the consistent speed of 500 that we set. So to do that, it's fairly simple. We say move and collide, because we want the bullet to be able to detect collisions as well. We want to see when it hits the enemy. And we're going to give it a vector 2. We don't want to move anywhere on the x-axis, so we're going to say 0 for the x. And for the y is negative to go up and positive to go down. So we want to say negative speed multiplied by that delta again. Save that script. And now if we launch the game and we hit the spacebar, we're going to get a bullet that fires straight up the screen and continues going. Great. The other thing to test is if we move along all the way over here to the left-hand side where we have our enemy, and we press the spacebar, you can see that the bullets start stacking up. They're colliding with the enemy and they're colliding with themselves, which is exactly what we want, but what we want is for it to hit the enemy and actually to destroy the enemy. So that's what we're going to do next. Okay, so we can close our bullet. And what we're going to do now is we're going to come into the bullet.gd script. And if we go to the documentation for move and collide by going to the kinematic body 2D, again, I mentioned before that the move and collide function returns something called a kinematic collision 2D. Now, if we click into this, we can see that we can actually get access to the object that we collided with via the collider property. If we scroll down, you can see that the collider property, we can get the collider there by calling the get_collider function, and that will get us the colliding body that we actually collided with. So we're going to do that. We're going to say bullet.gd. We're going to actually say var collided object equals move and collide. And now what we want to do is we want to check if we actually did collide with an object. To do that, it's quite simple. We say if collided object, then, oh, we forgot our colon there. So if collided object, so basically if we have a collided object, then we're going to call collided object dot q_free. Now what that's going to do is it's going to delete the object from the tree. It's going to request that this object gets deleted. What we also want to do is we want to delete the bullet itself. So if we've collided with an object, not only do we want to delete the object that we've collided with, but we want to delete the bullet as well. So we're just going to call q_free on ourself. We're going to save this. We're going to press play. And now we're going to move over. You can see that if I press space, we're shooting bullets again. And if I move over to where the alien is, we press space, and we get a crash. Okay, so what we can see here is that actually, when I looked at the documentation before, and we looked at the getCollider object, so the getCollider method, you'll notice that I haven't actually used it. So this wasn't an intentional error, but actually it's really useful for you to see how errors actually occur and how you debug them. So if we come back to the script, you can see here at the bottom we have this debugger, and we also have some errors here as well. But if we look at the debugger, it says invalid call non-existent function q_free in base kinematic collision 2D. Now that's true. If we go to the kinematic body and then we go to kinematic collision 2D, there is no q_free function. But if we go back to bullet and we change this line here to collided object, we do collided object dot get collider dot q_free. Save that. I'm just going to quickly double check that. So kinematic collision 2D collider get_collider, and now we try rerunning this script. We move over. We could do with increasing the player's speed as well, so I'll show you how to do that shortly. We fire, and the bullet and the alien ship now get destroyed, which is great. Okay, so now the other thing we need to do is make the enemy move. So it's all well and good having this enemy there that just gets destroyed, but obviously we want to add some artificial intelligence to this enemy. We want to make him fire back and all that sort of stuff and make it, a really hard boss. We're not going to do all of that in today's tutorial, but we are going to make the enemy move right across the screen just to show you how we would get some sort of enemy movement in there. Obviously, you could then take that, you could extrapolate that into movement on the left-hand side. You can bounce off the wall and move off the right. You could have a staged approach where he moves like right, down, left, down, like he does in Space Invaders. But for now, we're just going to make the enemy move right across the screen. And to do that, we're going to click on the enemy, click into his scene view here, right click, attach a script. We're going to press create. We're going to give him a speed, just like we've done for both of the other scripts so far. So speed equals, let's say 200. We're going to set the physics process to true. You should be familiar with most of this by now. And we're going to create the function, func_physics process. We're going to say move and collide. We're going to pass it a vector2. And we want him to move speed multiplied by delta on the x-axis, 0 on the y, and we're going to save that. And now if we press play, we should see that the enemy starts moving along the screen. And what we can do here is we can go back into our main scene, into the 2D view. We can press Ctrl D on the enemy to duplicate him, move him along, Ctrl D, and we're just going to create a few of these enemies in varying locations. That should be enough. And if we press play, we should now be able to destroy these enemies. One thing I am going to do is I'm just going to show you how easy it is to modify every single instance of an enemy or a scene in general just by making a change in one place. So if all of these enemies would have been completely separate objects with completely separate scripts, if we want to change the speed of them, for example, we would have had to go into each individual one and make the modification however many times there are for however many enemies there are. But given that we've made them scenes and we also have assigned the same script to them, we can click on any of the script icons here. We can change the speed to 100, save that, run the game, and now every single enemy will be moving significantly slower. The other thing that I said that we could do is we could increase the speed of the player. Now sometimes it's useful not to have these values hard-coded, and it's actually useful to have these values modifiable by, whoever is creating the level. For example, you might want a level where the player can move a little bit faster, or maybe a level where he can move a little bit slower. To do that is really simple. We click on the player.gd script, and in front of the var speed, all we need to do is type export and a space. Now if we save that and come back into our scene view, click on the player object, you can see on the right hand side now we have this script variables, and you can see we have speed 100. So now we can change that, say to 400, press the play button, and now our player moves significantly faster than he did before, which should give us a bit more of an advantage when it comes to playing the game. And that's it. That's your very first game in Godot. We've made a very simple version of Space Invaders with a player, an enemy, the player can shoot bullets, and we can destroy aliens. If we wanted to make further modifications to this, we could create new scenes, such as a game over screen and a success screen. We could make more levels. We could create enemies with more complicated AI. And maybe I'll do a follow-up tutorial in the future with all of that in. If you really, really want to see that, then please leave a comment down below. Let me know what you'd like to see. Let me know what you'd like me to cover next. I will be doing some basic programming tutorials, some basic GD script tutorials as separate videos. So combine those with the tutorials that I make for actually creating elements of games and functionalities, and you should be well on your way to creating some amazing content in Godot. So there you have it. You've created your very first game in Godot. Congratulations. We've created a Space Invaders clone with a player that can shoot bullets and enemy ships that can be destroyed. You could take this on to create game over screens, more complicated AI, perhaps different weapons that the player could fire, a magnitude of different things. Your imagination is the limit. So, if you enjoyed this video, please click that subscribe button down below and hit the notification bell to hear when I release new content on the channel. If you really enjoyed this video and you'd like to see more, please leave a comment down below. Let me know what you would like to see. Thank you so much for watching, and I'll see you guys in the next video. What's going on, YouTube? Too loud. I really hope you enjoyed this tutorial. We can cover future to be notified when I release new tutorials. I'm planning to do much more things. I'm planning to do